Okay, to wrap up the videos for this week, I do want to talk about law of cosines because all of this goes together so nicely. I'm sure I'm going to give you ample time to work through anything you need to along with the Q&A. So, law of cosines today. So to warm up on this, law of cosines kind of goes with law of sines. And so let's look at this one. Suppose a boat leaves port, travels 10 miles, turns 20 degrees. Ooh, it's turning 20 degrees. So that put it outside my realm right there, but I'm pretty sure that guy's going to be 160 thanks to my linear pair postulate. And then travels another 8 miles. I want to know how far the boat is from the port. So using law of sines, go ahead and tackle this one and see what that x is going to be. I'm going to hit pause on the video, and then you come back and see if it works. Hopefully you weren't gone for long. You realize that there is no way to find an angle across from a side. I don't know what's across from that 8 miles. I don't know what's across from the 10 miles. I don't have any way to use law of sines on this. And so we do have this need whenever we're given, what are we given on this one? We're given side, angle, side. We haven't worked a side angle side problem yet, so we need that law of cosines. And so law of cosines is going to be very helpful when we're dealing with side angle side, or if we're dealing with side side side. And this is it. Unfortunately, it's not a ratio like the last one, but anyway, part of this looks familiar to me. I know angle B here is probably not a right angle, but suppose angle B was a right angle. I'm going to use this one right here. If angle B is a right angle, cosine of 90 degrees, that's 0. 0 times anything gives me 0. Look what I'm left with. My Pythagorean theorem is just a special case of the law of cosines. It's just I have this little added bonus on here. Again, I am fully prepped for you guys to have a note card on the upcoming assessments. We are not going to have right angles, so I'm going to get rid of that right angle because we're still going to be on the idea of oblique triangles. And as you can see, all of these work the same. If you search the internet, they have some alternate, they rearranged the law of cosines to solve for A, or cosine of A at least. I'm not going to include those on here. I want to keep it just basically these. Now, you say, well, which one do we know to choose from? Well, it depends on which side you want. Whatever side I'm looking for, I'm going to use. And it's not too hard to come up with because I still have the a squared equals b squared plus c squared. So the two sides that I'm given are going to be plugged in for b and c. All right? And then the angle that's included will go here at the end. So it doesn't really matter what side I'm given. I'm going to just do the sum of the other two sides squared minus the product of 2 times the other two sides times cosine A. Okay. That looks daunting. I'm sorry. It's not as daunting as I'm trying to make it look. All right. So we just have some, again, it's going to say solve the triangle. And you got to know when to use law of sines, when to use law of cosines. I plan on just telling you solve the triangle. And so you've got to realize on this one that there is no way for me to find out an angle and a side across from it using law of sines. So I've got to jump on this law of cosines. And the angle, or the side that I want to find first, is going to be this A right here. This A is right across from this 49-degree angle. Okay? And so I'm going to use that very top line that was on my formulas on the last slide, the one that said A squared equals, I'll just write out the whole thing. B squared plus C squared minus 2BC cosine A. Make sure that calculator is still in degree mode, all right? Hopefully you haven't moved it. And so my goal on this is just going to be to find out what A is. And so across from B is 5. So this be 5 squared. And across from C is going to be 7. So it's going to be 7 squared. Minus 2 times 5 times 7. See how these numbers just kind of repeat? Times cosine of 49 degrees. Now, some of you are really good at making your calculator do this little song and dance all the way across, and you get the answer. Kudos to you. I am just not that willing to try it. All right. I know that 25 plus 49 gives me 74. So I just do little bits and chunks at this at a time, and then I have all of this to type in the calculator. So I have 2 times 5 times 7 times cosine of 49, which gave me like 45.92 and some change. Okay. Now to keep my problem going, I'm just going to do 74 minus that answer I just got, and it gives me 28 point, I don't know, 0.7 or 0.8 and some change. Okay. Now that looks way too long for this side. I don't think this side is going to be 28 and some change. It's because remember, that's what a squared is equal to. I need to take the square root of both sides. So I still have not cleared my calculator. I'm going to hit second square root, second negative sign, that answer I just got, and it gives me, and we're going to do a side here, so let's do 1 decimal place, so 5.3. 5.3 on that, not the 28, 5.3. That's good. Now I know all 3 sides. So to find, I don't know, angle B down here, I could just use my second formula and plug in all 3 sides in for A, B, and C and solve it. And we're going to do that in a minute. But you know what? I got really good at law of sines this week. And look, now I know that the angle across from 49 degrees, I'm sorry, the side across from the 49 degrees is 5.3. And I can use my law of sines to find another angle. I'm going to find my small angle when I'm dealing with law of sines. That's just a good rule of thumb for me. We'll talk about it why later. Right? And so I know how to solve this for B. I'm going to kind of skip the steps on the board. I'll write down the first step. So I'm going to do 5 sine of 49 degrees equals 5.3 sine of B. Now, I'm looking for angle B on this one. So this sine, whenever I do 5 times sine of 49 degrees and divide it by 5.3, first of all, you don't have to worry about an ambiguous case or 0 triangles or 2 triangles with any of these type of problems. That's only reserved for the side-side angle problems that was in a previous video. Okay. So I get sine of B is equal to I'll just do 5 decimal places, 71199. And yes, I've got to bring this sine over, so I'm going to end up doing sine inverse because I'm looking for an angle. Again, I'm not going to hit my clear button. I'm going to hit second sine inverse of that answer I just got. And we'll just do to the nearest degree on this and leave it easy. So I get 45 degrees for angle B down here. I want to let you know, and I'll do this in a minute, I could have found that angle using law of cosines. I just got so good at law of sines earlier that I'm going to go to it. Okay. Now for angle C right there, I'm still using the triangle sum theorem where there's 180 degrees inside every triangle. Ooh. Since I'm making a video, I'm not doing math in my head. But yeah, that angle C up there, that looks about like 86 degrees. To have the triangle drawn for you, a good ACT trick is to make sure the answer kind of looks like what we have. So in the drawing. That looks close to 90 degrees, maybe a little bit less, so I'm good with that. 3 answers, all of them circled. Mr. Lovelady can easily find them. All that looks good. So let's just recap. I did a law of cosines, law of sines, triangle sum theorem, and that will get you through all of these solving problems. If you really like the law of cosines, you can definitely go law of cosines, and then triangle sum theorem. Or you can do law of cosines again. I don't know. I just like my math to get easier as I work through the problem. Okay. Let's work one that's side, 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 and then I'll let you practice one on your own. As you can see, we're not given an angle here, okay? We can talk about it later, but I always, whenever I'm using law of cosines, I always want to find my biggest angle first. And I remember from geometry that my largest angle is going to be across from my largest side. So that's going to be angle y in this case. We're off A, B's, and C's. You can switch from A, B's, and C's if you want to. But angle y is going to be the largest. And the reason I want to do that, whenever I use law of cosines, well, I'll show you. Let me go ahead and write it down. Okay, so I don't have an A, B, and C. I'm just using I'm going to find angle y, though. So that means at the very end of this, I'm going to have cosine of y. And so what goes first, just 7.9, is going to be over here in the position that's in front of the equal sign. My other two legs go on what I call the business side. I'm going to have to move over mine. Cosine of y. Right there's good. 2 times 3.5 times 5.1. Okay. So let's talk about this. The reason I want to use law of cosines to find my biggest angle is because, remember, I'm going to end up moving this cosine over and doing cosine inverse. Well, cosine inverse will gladly tell me anything that's in quadrant 1 or quadrant 2, anything between 0 and 180 degrees. So it tells me all of it. So if this angle turns out to be obtuse, law of cosines will tell it for me. Law of sines has trouble with that. Law of cosines does not. Okay? Just kind of try to preserve some of these decimals as you go. It's going to be hard to do. And again, if you can make your calculator do this dance all in one step, that's awesome. All right? So I'm going to do just this part right here gave me 38.26. Okay. Minus, let's see, I've got 2 times 3.5 times 5.1. It gave me 35.7. And that was just this part right here. Okay. I'm going to go ahead and square my 7.9. 62.41. I haven't had to round anything yet, okay? Be careful, I got this cosine of y right here. Now, the number one mistake people make on this is they do this subtraction right here. No, don't do that. You cannot do that subtraction. Think of it two ways. They're not like terms. This guy has a cosine of y tagged onto it when the 38.26 does not. Or think of it this way. I've got to take care of multiplication over here before I do any subtraction. I cannot do that, okay? So instead, what I'm going to do is I'm going to subtract off the 38.26 from both sides. So yeah, I'm going to have some algebra on this one, okay? If I mess it up, let me know. 62.41 minus 38.26. So that gave me 24.15. Equals negative 35.7. Ooh, notice I brought down the negative. All right, not letting that throw me off. Okay, now I need to divide both sides by this 35.7. And so that will leave me with just cosine of y. And I'm not even going to type that in. I'm just going to leave it 24.15 over negative 35.7. And then I'm looking for y right here. So I am going to take cosine inverse of this fraction. Okay, so I'm going to hit second cosine this time. 24.15 divided by negative 35.7. And sure enough, it came out big. Y turned out to be an obtuse angle. So if I didn't find angle y first, and if I messed up the order in doing stuff, I would have had trouble getting all the correct answers on this. So big note on your note card, law of cosines, find big angle first. 132 point, oh, we're just doing angles, so let's do 133 degrees. Now the good news is, if my largest angle in a triangle is obtuse, the others have to be acute. Law of cosines won't have any problem with that. But if my biggest angle down here, suppose this would have been acute, if my biggest angle is acute, notice both these angles, x and z, also have to be acute. Because my biggest angle was acute. The other ones have to be less than that as well. So I've taken care of that already. Remember my order of stuff. Law of cosines, as you can see right here, can get messy. So I'm going to jump ship and I'm going to go to law of sines. I now know that y is a 133 degree angle, and I know the side across from it is 7.9. Right? And then from here, I know both these angles are going to be acute, so it doesn't matter which one I find. I'll just find x first. So sine of x over across from the x is 5.1. Okay. So sine of x will be sine of 133. I'm going to go ahead and show my division step on this one. Hopefully you're kind of getting to there. And then I'll end up taking sine inverse of it. But let's go ahead and just do sine of 133, close the parentheses, times 5.1, divided by 7.9. So yeah, I got something nice. I'm going to be able to take sine inverse of it. So I got like 0.472139. I'm going to hit second sine inverse of that answer I just got. And I got my angle x to be, we're just going to the nearest degree on this. Or just leave it easy, 28 degrees. There's still 180 degrees in a triangle. So whenever I'm looking for angle z, I'm just going to do 180 minus these two angles. Oops, I hit 433. 133 minus, 180 minus the two angles I just found, which gives me 19 degrees. So your answer on this one, it's kind of weird. It's 3 angles on this one because they gave me the 3 sides. I want to give it the 3 angles. Okay. Again, law of cosines, law of sines, triangle sum theorem. All right, I'm not even going to draw the triangle on this one. I'm going to let you play with this one, and then we'll come back and you can see my work if you got some. So go ahead and hit pause on the video, and then I'll get my work up here as well. Here are the 3 answers I got, just rounded to the nearest degree. Notice over here in blue, I started with angle C because I know angle C is going to be my largest angle. I have to find either my largest angle first or last on these in order to get the right answer. Let's go ahead and just get it out of the way. I actually like to work it so that my angles get smaller. So I found angle B next. It was a little bit smaller. I found angle A last. Oops, I misdid that real quick. Bad. Let's call this A. I found angle A last. It was the smallest. It gets good because it's across from the smallest side. Now, they'd have to give you a drawing on this one. I don't see how they would get around it, okay? But I'm going to give you some word problems to work on this week and this weekend as well, okay? So 2 airplanes leave an airport at the same time. Okay? 2 hours later, they are 321 kilometers apart. Now, when I first read this problem, I'm like, okay, they're going in opposite directions. That's cool. But then I realized, well, that won't form a triangle. So I'm going to let this guy down here be my airport A. And then I'm just going to form my triangle like this, okay? And it says that 2 hours later, they're 321 kilometers apart. So my airplanes are going this way, all right? I'm trying to make them look equal or parallel, but yeah, my airplanes are flying at that angle. Now, plane 1, I'm going to let this be plane 1 over here on the left side right here. It says it traveled at 244 kilometers per hour. Well, plane 1, if he goes 244 kilometers per hour for 2 hours, I have a feeling that he went 488 kilometers. Remember, the sides of these triangles are distances, not speeds. They're going to be speeds later, but right now they're right now they're distances. Okay, I'm going to let plane 2 be this plane, going up this way. Okay, it traveled 168 kilometers per hour for 2 hours. So if a plane travels 168 kilometers for 2 hours, let's see. Oh man, this math's a little bit harder. What would that be? 32, 33, 33, 6. They're laughing at me. This is the 4th video I've made today, so I have the right to get that. Yeah, I got it right, 336. So that means this length right here is 336. I had to draw my own triangle on these. I want the angle between their flights. One saving grace of working word problems with law of sines, law of cosines, is that it usually just asks for one piece of information. In this case, it just wants the angle down here by the airport. Again, it doesn't really matter which one I use, but if I'm going to use cosine of theta at the end of this, I've got to go across from it. So that 321 has got to camp on a side by itself. And then the flight of the two planes will be over here on what I'm going to refer to as the business side, like all the math. $336. Whew. And then we're doing cosine. Law of cosines, we use cosine. As you can see, we just have a horrible computing problem right here. I'm going to pause the video for a second and work this out, and then you can see if we get the same thing. Okay, I'm just now wrapping up this problem, taking cosine inverse of that nasty fraction. Notice I got two negatives, and it's going to equal a positive, so I expect to have something in the first quadrant on this one. So second cosine of 247,999 divided by 32793, domain error. What did I do wrong? Let's try it again. I'll leave off a number. Domain error. Oh, I left off a number. Let's add that 6 on the end of that and see if that makes a difference. I think it will. Second cosine 247,999 divided by 327936. Yeah, 41 degrees. Pretty accurately. That would be 41 degrees, so that would be my answer. Large numbers on there, don't let those scare you. Do it with big or large, or big or small numbers. Let's go back and revisit that first problem. I'm going to let you handle this one. I've already got the triangle drawn for you. I'll also go back and look at what I did to mess with this a little bit, but let's find out how far the boat is from the port. So hit pause, and we'll work this one separate as well. I got 17.7 miles on it. I'll tell you, I got 3.7 up front because I goofed up this negative sign in here when putting everything in. So be super careful. Make sure your answer makes sense. 17.7 makes way more sense than 3.7 for this distance of x right here. Here's some problems to work. I'll be basing your quiz off these problems, so have questions ready for me.